Okay, question number 4. We have 5 parts altogether. It says, suppose a company just purchased a new computer for $2,800. The company chooses to depreciate using a straight line method for 4 years. Okay, so we're going to write a linear expression that expresses the book value V of the computer as a function of its age. We're going to write what its domain is from part A. We're going to graph the linear function. We want to know what is the book value of the computer after 3 years. And then we want to know when will the computer have a book value of 2,100. Okay, so based on the information that we have the computer costs 2,800, and then they're going to depreciate it for 4 years. Okay, so that means after 4 years it will be obsolete and have no value. So the first thing we need to do is figure out what our rate of change will be. So this is what we will do. We will say b of x, which is that's the variable that they show here. That's the function notation. The value of this computer equals, and I'm going to rewrite it in slope intercept form, but I'm going to write it as the 2,800 that it cost minus some amount of money times x, where x is the number of years. I think that's what it says. X is its age. So for 4 years. Okay, so what we're going to do is we're going to take this 2,800, divide by 4, and that will give us 700. So that means that this computer will go down in value $700 per year. So we're going to say 700x. And we can rewrite this in slope intercept form, but either way, this is fine. We can write it as b of x equals negative 700x, and then we'll say plus the 2,800 that it costs. Okay, so this will be our function. Alright, so since this is a real world scenario, now before I've talked about when we look at domain, if we don't have a fraction, if we don't have square root, if we don't have logarithm, it will be all real. Now this is an exception when you have real world scenario. So since they've already told us that this computer will depreciate for 4 years, then our domain, okay, the number of years that we can use this computer will start at year 0 when we first get it and go up through 4. So our domain is 0, 1, 2, 3, 4. Or if we count, I think we want to just do years. I think we will just list it like this. If they want to count like half years, like all the way through, then it is possible for us to say from 0 to 4, because time is continuous. But if we want to just look at years specifically, we will list 0, 1, 2, 3, 4. But let's see. So first we're going to write our function. Our function is negative 700x plus 2,800. Alright, so we're going to choose the correct answer below. Okay, so they just give us 4 options. Now, I put it in interval notation. We actually do need brackets, okay, because 0 is included and 4 is included in our years. We actually do reach 0 and 4. We start at 0, we go to 4. So we're going to be doing 0 to 4 in this interval notation. It's a closed interval, 0 to 4, because we're only going to 4 years, a real world scenario. Now, part C, we're going to graph the function. Okay, so if we were to graph this just by hand, and we can look at it on the calculator, but we'll do it by hand. When you graph a linear equation, you want to start with your y-intercept. So we would go up, let's say these tick marks count by 700. So 7, 14, 21, 28. So this is 700, 1,400, 2,100, and 2,800. We would start at year 0. Our computer is worth 2,800. I'm going to go 1, 2, 3, 4. So this is 0. X is 0. This is 1, 2, 3, 4. So we start at 0, 2,800. And then at year 1, we go down 700. So go down, right 1. So down 700, 1 year. And then down 700, another year. Down 700 after another year. Down 700 after another year. So after 4 years, this computer has completely no value. You'll see a linear decreasing function that way. And it's hard to get all of these in view. Let me see if I can make this full screen and get a better view. Okay, so we don't want an arrow that continues. That means this goes on to infinity. Okay, we want it to stop. It starts at 28, goes down. So this is the option we want, because real world scenario, this computer is not going to have value. Negative years before it was created and have a higher value, and this is increasing. So this is not what we want as well. So D is going to be the best option here. Okay, now part D says what is the book value of the computer after 3 years. Okay, so based on our graph, we can see 1, 2, 3 years. Our computer is valued at $700. You can also just plug in a 3 here and then evaluate it. You can do V of 3. You can do it this way. So I'm going to plug that in. Negative 700 times 3 plus 28. Okay. But with a linear equation, you have the equation, you have a graph, and you can make a table. And all 3 of those are 3 different representations of the same information. So, let me see. Oh, we just have to plug it in here. So our graph, or our computer, is valued at $700 after 3 years. Just from using the graph. And then after blank years, the computer will have a book value of 2,100. Okay, so 2,100 is here, so that's after 1 year. So trace that up. 1 year, we have a value of 2,100. So that's after 1 year.